All right, let's have a look at this problem called single-threaded CPU. It's a big one, so it will take us some time to read. Let's have a quiet read. You are given n tasks labeled from 0 to n minus 1, represented by a 2D integer array tasks, where the tasks of I equals to nq time processing time, means that the ith task will be available to process at nq time I and will take processing time t. Okay. So, for example, in this input, this task, it is available, it's enqueued at t equals to 1, and it takes 2 units of time to complete. This task is enqueued at t equals to 2, and it takes 4 units of time to complete. We have a single threaded CPU that can process at most one task at a time and will act in the following way. Okay, let's see. If the CPU is idle and there are no available tasks to process, okay, then the CPU will remain idle. If the CPU is idle and there are available tasks, the CPU will choose the one with the shortest processing time. Okay, so out of all the tasks that is available at a given point in time, it will choose the one which has the shortest time. If multiple tasks have the shortest processing time, it will choose the task with the smallest index. Okay, so if task A and task B both are available to be processed and both have the same processing time, then A will be done just based on the index. Once a task is started, the CPU will process the entire task without stopping. Okay. The CPU can finish the task when a new and then a new one instantly. Fair enough. Return the order in which the CPU will process the tasks. All right. Some big example is given. I've also taken one example. Let's switch to the whiteboard and look at that example. So let's consider that this is the example that is given to us. So I have taken, let's say this is the input array, and I've defined these tasks, or I'm calling them jobs, right? And so job 0 is available at t equals to 11, and it will take 3 units of time to process. Similarly, J1 is available at 4 units of time. The J1 will be available at t equals to 4, and it will take 1 unit of time, right? That's the general idea. So the first question will be obviously, which is the first job that I'll pick up, or what are the candidates of choosing the first job? So available, obviously, jobs will be done as and when they come, right? So first things first, I have to sort these jobs based on their start times, right? Because that's when the CPU is idle to begin with. When the first job comes, so here the first job will come with the first job that comes will be J1. So let's take a time series, all right? So let's take a big time series here, and let's define this as t equals to 0, t equals to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, let's say this is a time series. Now let's see when each job is available. So J0 is available at t equals to 11. So this is when J0 is available. J1 is available at t equals to 4. So this is when J1 is available. Let's look at all others. So this is where J2 is available. This is when J3 is available. And this is when J4 is available. And t equals to 11 is also when J5 is available, right? So that's the first order of business, right? So essentially, that primarily might mean we might have to sort this initial array of jobs in based on their start times. Now CPU will process the jobs one by one, right? So at t equals to 1, CPU was idle and a job is available, so it will pick it up. So J2 will take 2 units of time to complete. So that means till here J2 will be done. And now at t equals to 3, so J2 is done. What are all the jobs that can be processed? J3 and J4, right? So out of J3 and J4, which takes less amount of time? J3 takes less amount of time. So we'll do J3 here, and it will take 2 units of time. So we will do J3 at t equals to 5, and now so J3 is also done. Now between J1 and at t equals to 5, what are the tasks that are available to be picked up? They are J1 and J4. So out of J1 and J4, which are smaller? J1 has only 1 unit of time. So I'll do J1 now, right? So this at this point, I'll do J1 and I'm at t equals to 6. At this point, J1 is also done. Is there any more job that has to be processed that is already available at t equals to 6? And the answer is yes. So at J4, so we can do J4. Now, how much units of time J4 takes? 4. So 6 plus 4, 10. This is where J4 will be done. At t equals to 10, is there any job that is there to be processed? No, there is no available job. All the jobs that came in so far have been processed, right? So you just move on, you just chill till a new job is available. So at t equals to 1 is when the next job is available. At t equals to 11 is when the next job is available. So, and that is J0 and J5 both are available. So J0 takes 3 units of time and J5 takes 2 units of time. So I'm going to first do J5 with 2 units of time, right? And at t equals to 13, is there another, so J5 is there another job available? And yes, J0 is available and J0 will take 3 units of time, right? So this is how my J0 will be done. So that's the logic, right? So there are two things, right? First is we want to consider jobs only when they are available, right? That's the first bit, which is consider only uh, available jobs. And how do you do that? This will be done based on sorting by start times or sort by NQ time, right? And then the next thing is out of available jobs, you have to also choose a job out of available jobs, right? So out of available jobs, how do you choose? This is based on their processing time. Now, if a job came at t equals to 1, another job came at t equals to 2, but if I'm looking at t equals to 10, then all of those are available. Now the start time doesn't matter. Out of all of these available jobs, you have to choose based on their processing time. And there was one more condition which was mentioned, which is if the processing time are same, then uh, choose based on their index, right? So all of that is fine. So this sorting can be done. How can we do this bit? So for example, here what we did, uh, of all these jobs available, of all the available jobs, I have to choose the minimum one, right? Minimum based on the processing time, and then I will be adding more jobs as well into the queue. So what can we use for that? For that, we can use a priority queue, right? Right. So for this bit, we will use a priority queue, which will do the sorting based on this. All right. So the logic would be we first sort everything based on their start times, and then we will consider, to begin with, we will consider all the ones which are the same start time, right? And then all which have the minimum start time, we will put all of them, or basically whatever is the current time at this point. If there are any jobs that are available, just enqueue them into the priority queue and one by one complete them, right? That's a bit. So let's come to the logic and code and see how to implement that. So what do we do? Okay, so because we have to ultimately return the indexes of the jobs, we have to save index with the job, right? So let's define a different class called job, and in this we'll give it this task, and we'll also give it an index, right? And let's create an array of, or like a list of jobs. Let's to give it a constructor. So public job, you give it index and you give it this task array, and you can do this dot index equals to index, this dot task equals to task. Now I can call it jobs. And now for each, okay, I equals to 0, I less than length, I plus plus. I'll add all of these into this list. So jobs dot add new job I equals to whatever I is and whatever this is, right? So now I converted this each job into an uh, each task into a job object, essentially using that to also save the index along with the job. And now I want to sort these jobs. So it's now a list. So collections dot sort. I want to initially sort them based on their start times, right? So I sort these jobs based on their start time. So I'm gonna do like a constructor or a comparator rather. So I can give this lambda expression where I'm gonna do this. I'm gonna do a dot task of 0 minus b dot task of 0, right? So now I have sorted them based on the start time. Now what else to do? Uh, let's initialize. Let's also have a priority queue. We're gonna need a priority queue to of jobs, and this will call available jobs, right? So the available jobs priority queue will be new priority queue, and here I am going to look at two things, right? One is okay, so this is a bit complicated. So this is only priority queue, and a b will return what? So it depends upon, well, first thing is what about their processing times? If a dot task one, if they are equal, b dot task, if both of their processing times are same, if both their processing times are same, then I'm going to return their index based on their indexes. So, and if they are not the same, then I'm going to return based on their processing times, right? So this is how my priority queue would be. Now let's let's take whatever the current time is and let's initialize the current time to 0. And what do we do? So we do, okay, so while and also let's maintain an index in the array. So let's maintain index is 0, and we have to return an output, right? So we have to return order equals to new int task length, and we can also define some order index. Now while the priority queue is empty, so while while we have not processed all the jobs rather, so while index is less than jobs.length, right? While all the jobs haven't been processed, sorry, jobs.size, what are we going to do here? If all the jobs haven't been processed, then we are gonna take the then we have to take the next, we have to move forward essentially. That means there are no jobs, so move forward till a job is available. So that means we'll move forward in time and we'll go to current time equals to uh, jobs dot get of whatever the current index is, right? Index dot uh, task of 0. This is the starting time or the availability time of the next job, right? So now we are at this time. Now at this time, whatever jobs are available, let put them into the priority queue. So okay, while there are jobs that are available, so while index, oops, so while index is less than uh, jobs dot size, and uh, basically I'm thinking that let's just clarify what the first job will be, right? The first job will be the one which is of the smallest time, as well as which also has the smallest processing time, right? So maybe either I could sort them here, or I consider all of those different all of them here, and either is fine. So I could potentially add all of them into the priority queue. Okay, so at this point I'm gonna do, and the current time of not current time, sorry about that. Basically all the jobs which have the same starting time should have to be considered, right? If that's the case, if there are multiple jobs that come in at the same time. Okay, fair enough. I feel maybe it's better to handle it while sorting itself. So you sort it in that fashion, right? So maybe, yeah, maybe I sort it in that fashion. So what I do here is, let's say I define a new comparator of job, right? And I'll have a public end compare end job 1 and job 2. So a return value would be task 0 based on their start times, right? But what if their start times are same? That's what I'm trying to handle, right? If their start times are same, then I'm gonna choose the one which has the smaller processing time. So, and but what if their processing time is also same, right? Still possible that the processing, if the processing time is also same, then you wanna do based on the index, right? And so you do this. Now you just have to then basically now if you're then it's easy, right? Then it's just this. And now you want to do add. So you're in the current time. You the next job is the one which has to be chosen. You have already sorted this based on the best case scenario. Like you will choose the one with the smallest time, with the smallest processing time, with the smallest index, everything, right? So if there is no available job, then you move to the point uh, when then you move to that point where a job is available. Choose the best job that can be taken from that point. Add it into the priority queue. So priority queue dot add, and I think this we are handling. So let's increment the index, and we'll add the okay. This is the current. So let's do this. So job j equals to jobs dot get index. Okay, and we can increment the index now. Current time is this guy's start time. So j dot uh, this is now my current time. Okay, and I add this job into the priority queue. Now I can check while the priority queue is not empty. I think I call priority queue as available jobs. Okay, available jobs. So while the available jobs is not empty, I'm gonna complete the job that I picked up, right? I'm gonna first complete the job that I picked up. So I'm gonna do so this job is done. When this job is done, my current time will increase by its processing time. And now what I want to do is all the jobs that are available till this current time. So while index is less than jobs.length, jobs.size rather, and the start time. So jobs.get index dot. If its start time is less than or equal to current time, all of those should be made available, right? So available jobs.add, jobs.get index. So this is fair, right? All of those jobs will be added to the priority queue. So now when this loop will come out, this loop will come out when you have completed all the jobs and there is no more job that is available. And when there is no more job that is available, but you have not done through all the job, that means there is a gap. That means you have to wait till a new job is available. And this is what this will handle. The next element in the list is the job to take. So take that job, add it into the available jobs, process it, and do the and repeat the process, right? Makes sense. And at the end of this, okay, we have to also update this order array. So when a job, this is the one, so we can do order of order index, and we can give it this whatever the completed jobs index was, right? Okay, and at the end of it, we will return the order array. How about that? Okay, let's run and see if it works. We get some errors, let's fix them. So line number 17, jobs.add, what does it say? What's the error saying? Cannot find symbol task of I. Okay, it's tasks. All right, and let's fix more issues. Line number 23, int cannot be dereferenced. Hmm. I guess it's probably in the way I have defined this comparator. I'm not too sure myself what the right way is. So collections.sort, I'm trying to sort based on a new comparator that I pass in. I think it's maybe just a capital C that might be causing a problem. I feel like. Let's see. Okay, still get some compilation error. Okay, you made this end instead of a job. So job J1 and job J2. All right, run. Okay, so both are accepted. Let's submit. And it seems it works. All right.